record on this computer. So welcome everybody to our CCNP class. I want to just share something personal with you. This is something I just realized. In fact, my wife mentioned it last night, but I didn't. Yeah, I guess it didn't really hit me. But 1 year ago today, well, not 1 year, 5 years ago today, on April 1st, I was actually rolled into the Shepherd Center on a gurney, basically paralyzed from the neck down. So it's been a long journey to get to where I'm at, but it's kind of wild to realize that in 5 years I've gone from being paralyzed to, in fact, 1 year later we had a thing come up to show 1 year later I walked back into the Shepherd Center through the same doors they wheeled me in, which was very neat to go and do. But if you're in Atlanta or in Georgia area, hopefully you'll never ever need the Shepherd Center. But if you ever do, they are a premier spinal cord and brain trauma injury rehabilitation center. They also have a multiple sclerosis center and a pain clinic. But just kind of share that because I thought it was something when I realized it today. It was kind of neat to say that in 5 years ago to where I am today is really kind of an amazing thing, considering tomorrow's Good Friday, and I actually was hit on Good Friday in 2016. So it kind of takes me back to think about that. So,
wow, the 5-year anniversary.
Yeah, 5 years, 5-year anniversary, which is hard to believe that, first off, to A, survive that long, B, to be able to do it. And thank you, Keisha. Yeah, definitely, it is a miracle without doubt that I can walk. So we continue to be thankful for it.
How was the arm? I remember it was what, 6 months ago when the
arm. It's sore. It's still real sore. In fact, it's sore because I got my second COVID shot the day before yesterday. And yesterday I was in a pretty bad way. I actually felt pretty rough yesterday, but it's okay. It's sore, but the great thing is I have full use of it even after I broke it like I did. So it's, well, as much use as I had before. I never really had full use of my right arm after the accident, but I've got back, a lot of it. Just there's still a lot of pain. But it's much better than it was. So thank you very much. Yeah, that was a rough fall. To break my arm the way I did back in August.
And that we're on the health issues. So is the wife doing? I remember around
she's
Christmas.
Good. She's doing well. She's doing very well. Thank you. She's
good.
Recovering and getting better and slowly but surely getting stronger. So we're all doing well. And that's one of the things I'm thankful for this coming up on the Easter weekend, that everything is going well. So, and do appreciate that. Appreciate thoughts and prayers. I want to talk a little bit about BGP. We talked last week. We started talking about BGP as an exterior gateway protocol, and it really is the only exterior gateway protocol. There used to be one called EGP, but it is no longer really in use. We have, hold on one second, folks. So with BGP, we used to have more than one exterior gateway protocol, but pretty much we only have one now. The big thing about BGP is it is designed to run between ASs. So when we talk about an AS, we mention autonomous systems as a group of routers under the control of a single organization, typically, say it's using one or more IGPs, typically using a single IGP, interior gateway protocol, with common metrics. So imagine like your campus network running OSPF or running EIGRP, that entire network could be seen as an autonomous system. Now, autonomous system numbers can be public or private numbers. It just depends on whether or not you're using received a public number from INA. The field was actually changed. It was only a 32-bit field, which gave around 4 billion addresses. But because of the fact that, it was much less at 32-bit, but now you can allow it to 4 billion ASNs versus the 65,000 that were available. To get a public AS, though, you must give proof that you have a publicly allocated network range. So in other words, you must have a public range. Proof that you have multiple connections. So in other words, you really don't need BGP if you've got a single way out of your network. BGP doesn't do anything much for you. and then demonstrate a need for unique policy for their providers. So we'll talk about how we can control a great deal of control that you have with BGP, but BGP's main idea is to control a multi-homed environment. So an environment where you are connected to more than one ISP at a time, or you have multiple connections to the same ISP. That is another way you can do it, although that doesn't really provide that much redundancy. So we see here the ASN 65512 to 65535 are private, as are 4,200,000,000 to 4,294,000,000 and change. So they are all private ASN numbers. So you could use those if you were to, for some reason, be running your own BGP network. So if you created your own BGP network and we're not connecting it to the internet for some reason. However, that's really kind of a weird thing because BGP's main purpose is to move traffic on the internet. It is a path vector protocol, which we'll learn about. We'll talk more about the metrics and all next class as we talk about the next chapter. But it does have what are called attributes or path attributes. And some of these path attributes are what are known as well-known mandatory. In other words, all implementations know about them and they must be contained in updates, in prefix advertisements. Well-known discretionary, all implementations must know about them, but they are not mandatory in the path or prefix advertisements. And then we have optional transitive, which are those that are known about and will move with the prefix advertisement. In other words, they're transitive through other ASs, and optional non-transitive, which are ones that will not move through another AS. The main way that we do, oops, I jumped way far ahead, sorry folks. The main way that we prevent loops in BGP is with the path vector, basically the AS path attribute, which is that when a prefix is advertised, that prefix has appended to it the AS that all the ASs it has gone through. So if you, in this instance here, you'll see that AS100 got back a path to its networks, and it noticed that its AS number was already in that path. It will discard that path because it would figure that that is a loop back through its AS. So the AS path is a well-known mandatory prefix path attribute. The others, there are multiple different things here. Now, this is something that did cause some confusion. I want people to kind of think a little bit about this. And this is not the only, there's address family identifiers, and basically we're talking about IPv4, and then we've got IPv6. And then with BGP, we'll talk about a little bit. There's other ones here, but we're gonna stick with these for right this second, just for simplicity's sake. Then under IPv4, we have Unicast, and then we have multicast. Now this, by the way, would be the subsequent address family identifier. So Unicast or multicast, which is what we saw under OSPF. And we have the same under IPv6, but we also have, again, there's a layer 3 VPN address family that we don't use a great deal, but it is actually available under, well, we don't use it in this class. It's used a great deal in ISPs, but we don't really use it in this class. Oh, okay. What's the clarification? You want me to go back? Let's go here. Go ahead, Keisha.
No worries. As I was reading this, I just wanted to clarify. So the AS100, when it receives the advertisement for the AS300, the only prefix that it will disregard is the 100, correct? Because it already knows about it?
Correct. Yes,
okay.
Correct. So imagine,
not the entire thing.
Right. So let's imagine this. What it's really showing here is that AS100 advertises the network 172.16.1.0. That one network is advertised AS200. Well, AS200 prepends its, meaning puts it in front of the 100. So this is saying that AS200 knows how to get to 16.1.0, and it learned it from AS100, and it's coming through 200, and it goes to 400 and so on. So what happens here is when it gets back, this one network, 172.16.1.0 in the AS path, it sees its own AS and will drop it. Now let's imagine this happens. Let's imagine the AS 200 though advertises, let's just say it advertises the network 10.0/24. So let's change this. Just change that one item there. Well, if we do that, I don't have my little pad today, folks. I'm not in my home office, so I don't have the luxury of my little pad, or I'd draw it for you. But if AS 200 advertises this network, it would come out from AS 200 to AS 400, and so it'd be 200, and then be 400, 200, then 300, 200, 400. AS 100 would accept that network from AS 200 because it doesn't see its AS number in the AS path attributes. Does that make sense, Keisha?
Sorry. Yeah, I was muted. Yes, it does.
Okay, yeah. So in this case, what it's saying here, it's only for that 1.0 network that it advertised itself. Other networks that didn't have its path in it would not be dropped. Now, any network prefix that it received that has its AS number in the AS path will be dropped. So that is a given. If it's the path if it has its AS number, it will drop it, because that is how it prevents loops. Now, the thing about that is kind of crazy is you think about how important BGP is and how simple that loop path mechanism really is. So any other questions on that?
Nope, that was the only question. Thank you.
Oh, you're very welcome. And stop me anytime, unmute and just say, hey, Kelly, let's talk about that.
Okay.
So, so address families, again, IPv6, IPv4 are our address family identifiers. And then we have subsequent, such as unicast and multicast. So when we start looking at these families here, that's what is meant by this. Now, by default, if you just start doing BGP, which we've done before, so we do router BGP, and type it in and go in. By default, the address family identifier that is turned on is IPv4. You can turn that off. We'll see that here shortly. But you basically, what happens here really is each address family that you enable creates its own database and configuration for the BGP protocol. That's why we also have BGP sometimes, especially when it's using multiple address families, it's referred to as MPBGP for multi-protocol BGP because it accepts multiple address family identifiers. For us, just remember that just means it's IPv4, IPv6, unicast, multicast, and then down the road, there's a layer 3 VPN family that we talk a little bit about. So inter-router communications, they do not use hello packets. That is something about BGP that is very different from other interior gateway protocols. You have to manually define your neighbors, and you have to activate your neighbors. You also have to have the ability to have TCP communication in order for BGP to work. So TCP port 179 will be the port that is the target for any communications on a router that is running BGP. Now the sources will be a random port just like any other communication, but BGP port TCP 179 is the port that must be reachable. The other thing that's really weird about BGP is that it can create adjacencies with routers that are multiple hops away. As long as it has the ability to get to that router via TCP, it can skip 10 routers and form an adjacency between those two. And that's a weird thing that can happen. And it's basically, it uses the underlying routing information base to get that TCP session. So here's an example of it. So basically you've got inter-router communication. So BGP peering is occurring between R1 and R2, but R3 for whatever reason is not running BGP. As long as R2 has a route through an interior gateway protocol or through a static route to get to R4, and R4 has a way to get to R2 and they can establish TCP communication, you could do a BGP peering directly from R2 to R4, even though they are not connected directly. Notice, this is something important. A default route is not sufficient to establish a multi-hop BGP session. So if you're ever working and doing a multi-hop BGP session and it doesn't work, check to see if you're trying to use default routes, because it will not work. You'll have to have an actual static route going over to the 1034.10 network instead of a default route. Now we talked about IBGP and EBGP. We discussed last week how this particular test only tests you on EBGP, external BGP between autonomous systems. It is possible though to run BGP internally as an IBGP, and IBGP prefixes do have an AD of 200. EBGP prefixes have an AD of 20. So you can notice how they're much more trusted. BGP is the most trusted routing protocol, external BGP, that we have learned about so far. Chris, thing about RIPS 120, OSPF is 110, EIGRP is 90. So that's AD of 20 is very low, and will be placed into the RIB, the routing information base. We'll talk more about that as we move along. So IBGP is typically used mainly in service providers where they're actually providing what's called transit connectivity, which is the ability for traffic from one AS to travel through the network and go to another AS. That is something you should not do on your enterprise networks. One of the reasons is BGP now has over 780,000 IPv4 prefixes alone. So imagine if you're trying to do IPv4 and IPv6, the number of routes would overwhelm most enterprise network routers. ISPs have routers that literally the router chassis itself is in the 6 figures. And then you're looking at $1 million routers that can really support this type of level of transit connectivity. We don't want that with our normal enterprise networks. The other thing with IBGP you got to be careful with is that BGP path attributes cannot be maintained inside of IGP protocols. So we end up losing our path attributes, which are extremely important. So you have to do some special configuration to get those to work. Really, the best way to do it is you got to have an IGP router and a full mesh for proper workings. We're worried more about EBGP, and the big thing here is IBGP, it does allow for multi-hop sessions. EBGP does not. So in EBGP, there will not be multi-hop connections. You're going to have to be directly connected to the neighbor you want to connect to. So the advertising router modifies the next hop address to the source of the BGP connection, sourcing the BGP connection. It prepends the AS to the existing AS path variable. You saw that earlier. So as it left 100 and went to 200, the path became 200, 100. Then 300, it was 300, 200, 100. So it prepends or puts its AS number at the beginning. And it makes sure that it does not have the AS path of the local router. And it will discard it if it does not meet that AS path check, loop prevention check. So in other words, if the network layer reachability information, which is the prefix information, has the AS path for that autonomous system that a router supports and is part of in it, it will drop it. It will not allow it to be placed into any of the BGP information sessions. Different types of packets. Type 1 is open, sets up and establishes your adjacency. Type 2 is the update, where you advertise, update, and withdraw routes. 3 is a notification, which can be an indication of an error condition, and a keep alive, which makes sure your neighbors are still there. One of the things about these different states that I will let you notice here is that as we're going through these, one of them is active. Active should not, if you ever see a router that's in active state in BGP, that's usually a bad thing. It means it's stuck in the establishment of a three-way handshake. Established means that you have a fully established BGP session. So let's look right here. In the first stage of the BGP finite state machine, it detects the start event, attempts to initiate the TCP connection with the peer. So we'll send the TCP connect over to the peer and attempt to get that. When the handshake is completed, you reset your connect retry timer, and you send an open message and state changes to open sent. So basically you go in, you do an open sent, and you wait for an open reply. So open sent, get your reply. Once that open send is confirmed, then we go to active, starts another three-way handshake. If it is effective, we get open send, open confirm, and then established. We actually end up down here. Once we end up with our established right here, then we are good to go and we start sending out our updates. So the key takeaway for me for this is you must have TCP connectivity between the two BGP peers for it to be established. Very important. Good news is configuration is very simple. You do need to think of it as if you're going to look about address families in a modular way, but it's really pretty simple to get set up. We're going to look at the parameters. We're going to look at the address family initialization and activating the address family on the peer. So if we look right here, we initialize the routing process with router BGP AS number. We can statically define the BGP router ID. This is very important, especially on routers only running IPv6. Okay, go ahead. Clarification question on the last prefixes. Go ahead. Which one? This one or this one? Keisha?
Oh no, that was the previous one in the chat. You've already passed that.
Oh, okay. Sorry.
Yeah, no worries.
All right. Just want to make sure I'm not missing something. All right. So if a router is only configured with IPv6, there's no way for the router to get its router ID, which is a 32-bit router ID, automatically. In other words, it can't pull it from loopback, can't pull it from an existing port. So we typically, even though it says optional, statically define the BGP router ID, we do want to do that as a step. The other thing is, it's funny, the router ID, even if you're only running IPv6 address family, the router ID is a 32-bit address that it looks like an IPv4 address. So, but you need to do that. You identify your neighbors with the neighbor IP address remote AS. And then you can do the address families if you don't want to use just the default of IPv4. If you're running multiple address families, you can do that. And then you activate the address families inside there. So let's just take a look here. So on router 1, what we decided to do is just use the default address family of IPv4, which is on. And so just did router BGP, autonomous system number, neighbor 10.12.1.2, remote AS 65.200. At that point, BGP on R1 for IPv4 is configured. You're good to go. Basic configuration. On R2, what they decided to do is to disable the default IPv4 unicast family, okay, and use the address family identifier and set up address family IPv4 neighbor 10.12.1.1 activate. So that's going to activate the neighbor here. And then it will then activate this neighbor, oops, I hit the wrong thing, activate this neighbor statement right here. So these two accomplish the same task. One of them just uses the address family identifier process. The other used the default address family, which is IPv4. Both work just fine. And you need to know both, because as we move into sorry, y'all, I got a phone call coming in. I got to send a voicemail. As we move into more advanced configurations for BGP, we will be using address families for just about everything we do. We can then verify that session by doing a show BGP IPv4 Unicast Summary, because remember, we're using the Unicast family, and we will see here that we have a neighbor. Its AS is 65.200, and we'll see the table version for our BGP table, in queue, out queues, and all of those different items that are available there. So here we see in queue, out queue, processed, table version, versions, all those things. And we actually see what version we're running, which is version 4. Should be version 4 for everything we do. And the current state of the BGP peer or the number of prefixes received from the peer. So looking here, we've not received any prefixes yet from that peer. I will tell you, my experience with BGP is it is very slow to update things. So don't be surprised if you make a change to a network and it doesn't immediately show up. Give it some time before you start panicking. Yes, Keisha, you're exactly right. The OSP version 3 and the use of the router ID is exactly the same type of concept for the router ID on BGP.
Yeah, yeah, I'm glad you brought that out too, because when we did this lab, like when we used to do it with the students in CCNA 4, that used to be one of the issues. We didn't wait. We didn't know BGP was slow, so we thought that it wasn't working.
It is so slow.
I did not know that.
It's very slow, and understandably, as we go through here in a minute and look at how prefixes are advertised, you can understand why it is slow, but it is a very, when you get used to EIGRP and OSPF, which pretty much instantaneously pass changes, BGP is extremely slow. You really have to take your time and say, whoa, wait a minute, I need to back up and just go get a cup of coffee, go to the bathroom, come back, look at it again. And believe it or not, it'll show up a lot of times. So now, BGP network statements, this is very important. And this is a key item that is so different about BGP. Typically, with all of our IGPs, we have advertised only directly connected interfaces. In other words, you can think about with OSPF, we even have a way to, in OSPF, we can use OSPF and router OSPF, autonomous system number. We can put in the network statement of 0.000.255.255. If we're really being lazy, 255.255. And OSPF, put it in area 0 or area whatever. And OSPF will then automatically advertise all directly connected networks into OSPF. But that's the key. It will only advertise networks that it has an interface in. BGP is different. BGP looks to see if it has a route to a network statement that you're putting in. So it could be a connected route. It could very well be a connected network that is on the router that is being advertised. Okay. Or it could be a static route that's already in the routing information base. Or it could be a route that is from an internal gateway routing protocol. But the key is, if you put in a network statement on BGP and there's not, so this network statement here, it checks in the RIB. If there's not in the routing information base of the router a path to that network, it must pass this, what's called the network validity test, the network reachability link information, or layer information, I think it's link information. Network layer reachability. They got that backwards. It's supposed to be NLRI, network layer reachability information. That's wrong. So NLRI, folks. If it fails that test, in other words, if I look into my RIB and I don't have a way to get to the network that's in that network statement, it will not go into the local RIB. It won't go into BGP database. But the crazy thing is, to this point, the only thing that's gone into any type of routing table database has been those networks that are directly connected. That's not true with OSPF. OSPF will advertise any network you tell it to, as long as there is a path in some form or fashion on that router to that network. And that is very different than our interior gateway protocols. And also, you think about it, the way it's used by ISPs, that has to occur with BGP. Otherwise, ISPs could not serve as transit ASs for other autonomous systems. They have to be able to have that ability. If it does pass that check, okay, the other thing we'll do then, it will look and make sure the route's not denied by any outbound route policies. So if the RIB check is good and it's valid, it passes the validity check, it goes in. It will then look at any outbound route policies. If that is not blocked in any way, shape, form, or fashion, which there's ways we can do that, and we'll talk about those. Then it goes into the adjacency RIB out, and it will then go out to the peers. So here we see here, the network statement is network mask. And you notice this is using mask, not inverse mask. But if we did this, if this is how we set this up, okay, and we then did BG address family this, there would have to be a route somewhere on this router to the 12.1 network and the 192.168.2.2 network. And I know that's a loopback. The 2.2 is a loopback that's probably being used for its router ID, quite honestly. but there has to be a route somewhere. It could be a connected route. It could be a static route. It could be a route learned by OSPF. Doesn't matter. As long as there's a route in the local routing information base that BGP can see, it will then advertise that if there are no outbound policies that block it. Does that make sense? So
Yes.
that's how it works for advertising out routes. Routes coming in are a little bit different. They come into an adjacency rib in, and then they are looked at with the inbound route policies. Okay. If the inbound route policies do not block it, it will allow it to come into the local rib. The local rib will check to make sure that it has again, a rib check. By the way, they're showing here two different things. The left-hand side is showing a network statement that is coming in from a local network that's being placed in here. So that's what we've already seen before with our local statements. This route coming in from the peers on the right-hand side. So we're kind of paying more attention to that. The local rib will look at it, we'll put it into the BGP database. It will look for a next hop and validity check. It'll identify the best path. And if that best path is available, and by the way, BGP only puts the best path into the BGP path table, it will then install it in the global BGP rib. So the other thing to know about is that this adjacency rib in, once the inbound policies are run against it, is actually, and it drops the needed routes down to the local rib, it dumps that adjacency rib. It clears it to free up memory. That's important because if you think about the number of entries that come into BGP, especially in transit networks like autonomous systems that are ISPs. So we do show BGP AFI SAFI displays all the contents of the database. One thing you'll notice here, and this is very confusing in the book, and it confused me, and I really don't know why this is the case. But you will see that it only displays the first network entry. Well, I do understand it's only showing the first network entry here. If there's a second, if it's blank here, that means this next item is another path to the same network above it. So in other words, so this second item here that is star alligator mouth, greater than sign, that is still for the 10.12.10 network. It's just another route to the 10.12.10 network, which says it's actually a local network, a local route.
So would that be like a low balancing situation? I mean, like an equal cost path situation?
No, it is not an equal cost path. In fact, the second route here is the preferred path. It's the best path. So in this case, you've got two routes to the 10.12.10 network. You've got one that is the 10.12.12, or you've got one that is quad zeros, which is directly connected. And if you look at this and look at the diagram in the book, you will see that router 1 is directly connected to the 10.10 network via 10.12.11. And so basically, this is another route to 10.12.10 locally, and it is the best path.
Okay.
So in the book, if you look on, and I don't have the picture, I'm sorry. Maybe
I got it. I thought that.
Yeah, here it is, right here. So look, here's the network. So you'll notice that router 1 is connected to 10.12.10 network. Well, it has learned, if you look back at this table, it has learned from router 2, see 10.12.12. That router has told it about the 10.12.10 network. But because it is also directly connected, it's 10.12.11. So it's got a directly connected route, and it has learned about it from AS 65.200, which that's what we're seeing here. We're seeing that it has learned from AS 65.200, even shows you, see how the path is right there?
Right.
So it's got two separate routes to the 10.12.10 network. But the best route is the route that is directly connected, which has the next hop of quad zeros. And
okay.
That's what that means.
And that's the one with that, what you say, alligator sign. That's what I remember us doing in the lab.
Yeah.
Okay.
Because you see here, if you look at up here, status code, the star means it's valid. The greater than sign means that's the best route. So R1 has two routes it knows about to get to the 10.12.10 network, but the best one is the directly connected one that is off of one of its interfaces.
Okay. Will
That
that
was,
sorry,
no, go
would that
ahead.
always be the case? The quad zero in this table here would indicate like a directly connected?
That should indicate a directly connected network, yes.
Okay,
Yes.
perfect.
Basically it's saying it's not going anywhere else, it's here local.
Mhm.
You see the same thing with the loopback address here. See how 192.168.1.1/32. The
Mhm.
best route is a next hop is quad zero, which basically is this router.
Okay.
So
Yeah.
that is confusing. So if you got confused by that, I don't know. I somewhat understand, I really don't understand why they didn't just put the network, because if there were 7 routes to the 10.12.1.0 network, you would have 7 blank spaces here. So to me, I would like for them to just put 10.12.1.0 again /24, and that way I would say I've got 2 routes to it. But either way, this is the way it does it. So just don't get confused by that. You'll see the opposite. See on R2, you got the exact same thing, except it's reversed. It has learned about 10.12.1.0 from 65.100 and also from its local interface. So the local interface has is a better route than the other.
Got it.
So here we see here again, indirect sources. So if router 1 wants to be able to actually advertise the 10.13.1.0 or 10.15.1.0 network with network statements, it would have to have some type of route to that in its rib. It could be static, it could be OSPF, EIGRP, it doesn't matter. I mean, as long as it's in the rib, it passes that validity check for the network layer reachability information, NLRI, network layer reachability information. Okay. So here we have redistributing. You can also do that if you want to. That is a possible way. You can redistribute routes from an IGP into BGP and typically not get into too much trouble. I would say almost, unless you're an ISP, and even with an ISP, I'd be extremely scared to do this. You have to have a lot of control. But if you're just a regular network, I would say never redistribute BGP routes into your IGP, because you could end up redistributing 780,000 IPv4 routes into your OSPF, and that would destroy your routers. You know, they would lock up, and you would be in a world of hurt. So redistributing into BGP, you can get away with. Redistributing BGP into an IGP, only with extreme caution, and if you really know what you're doing at the ISP level. I would still be a little scared of it though. So summarizing prefixes, one of the things we do here obviously is it provides the ability to make smaller prefix lists. It also allows us to keep flapping routes from affecting downstream routers. So there's a couple ways we can do static, or 2 ways we can do summarizing. We can do a static summarization. So creating a static route to null 0 for the summary prefix, and then advertise the prefix with the network statement. And then we're going to have the network layer reachability information in the rib because we did a static route. You can also do it with configuring just an aggregation network prefix, and then BGP will aggregate it and will create a null 0 route, discard route on its own for just like OSPF did when we were doing that. So here we can say we can do an aggregate address network subnet mask summary only AS set. Now we're going to learn, if we're not careful with this, we can actually end up with routers ignoring an aggregate because we didn't put the AS set, or we could get into trouble because of the fact that the AS set is not on, and it causes us to have our summaries do some weird things. Let's just look real quick at R2. R2 is going to do an aggregate address family 192.168.0.0 and a /16, and then 172.16 with a /20 there. And we're going to allow it to do that. Now, when we end up with this, the aggregate it does act like a new route with a shorter prefix length. So basically, the BGP router summarize it. The problem with this is that it does not advertise the AS path information from before the aggregation. So we don't get AS path, we don't get MED, and we don't get BGP community, which is a little bit dangerous. because of the fact that some routers won't install or will install a path when they shouldn't. So we really probably should be using the AS set, and that would then allow the AS path to travel with the aggregation. Otherwise, we're doing what's called an atomic aggregate, and with an atomic aggregate, we don't really see the AS path coming. So see, it doesn't really give you a full path. If we do the AS set summary only, it will pass the summary along. This is interesting because, especially as we look in this particular setup, they don't go into it as much detail as I would like, but in this particular network, both router 1, router 2, and router 3 are using the 192.168 network as one of their as a loopback. They're actually loopbacks on 192.168. Now, you'll notice R2 though did an aggregate address here for the entire 192.168/16. Because of this, if you don't set the AS set, R3 would accept this summary. Okay. Now it's going to ignore it for the longer prefix links that it already has for its local routes. But the problem could come in if a local route, the problem becomes that for those set of networks, R3 could try to send it to R2, then R2 may then try to send it to R3, and then R3 sends it back to R2, and so on and so forth. That could be a big issue. With this, however, this stops it. Basically, what they'll show you, if you look in the book, when you set the AS set, the summary route for the 192 networks actually drops out of R3's table because R3 sees its AS path in that summary. So it's a little bit different, but just pay attention to that as you look at it in the book, because it asks it it generates an aggregate address route, but it actually includes the AS path and preserves your BGP attributes, which is typically what you want to do. Now, multi-protocol BGP, it does support IPv6 and MPLS using what are called layer 3 VPNs. MPLS is not in the scope, fully in the scope of this class, and it's really not fully in the scope of even the next class. It's going to talk about it, but MPLS is basically in many ways, it's just layer 3 tags like switching for our inter-VLAN routing. But there is a new address family identifier for IPv6, and there are some new different attributes for multi-protocol reachability and unreachability. So in other words, network layer reachability information for multi-protocol is added with IPv6 support. So as we look here, obviously IPv6 has one address family, one subsequent address family for Unicast, and then also with multicast. And then IPv6 Unicast has 2 address families and a SAFI. Now you think about that, that's a little weird. Why does IPv6 have 2 Unicast address families?
Well, when you say 2, I'm thinking like one for the link local and one for the global unicast address.
Exactly. That's
Okay.
exactly one. Yep. That is why it has 2 for the unicast, because it has the link local and the global. Very good. Excellent. Here we see here a router being configured for IPv6 BGP. In this case, they turned off IPv4 v6 unicast. Now here's the weird thing again, even if you were not running any IPv4 on this router at all, notice how the router ID is a 32-bit address that is placed in there. So that is very weird, and that's just like OSPF v3 version 3, because the router ID is still a 32-bit address if you're running all IPv6. So they've enabled the IP address family IPv6, and they've created the neighbor and activated it. You still do have to have under router BGP, you still do have to put the neighbor statement with the remote AS, and then you activate it under the address family. And then same thing on the other side, you've got router 2, and you've also got router 2 advertising different networks, one of which is a loopback. show BGP IPv6 unicast neighbors, and then the IP address actually shows you the address or shows you the neighbor, that particular neighbor, tells you how long the session has been up, what the remote ID is, all the different capabilities of it. Here's the Unicast summary, just like the others, that shows you that 3 prefixes have been received from that neighbor. So pretty much exactly the same other than IPv6. Show IPv6 unicast, you'll notice it does the same thing if there are multiple routes. Okay, we'll ignore the second one and then use the best route, : by the way, is all zeros. So remember, that means it is a local route. So that was learned locally. Same concept here, the greater than sign means that is the best path. So looking at this routing table, I can tell you that this particular router has 2 routes to the 2001 DB8 0:12 network. The best possible way to get to that is through a local interface, : The other one was learned via 65-100. So it was learned from another autonomous system. You can summarize just like you can with regular routers. Summarization is a little bit harder on IPv6, but you just have to think hex instead of binary. So it's not impossible. You just have to kind of think about if there's 2 bits needed, you would do :3/64, 3 bits for 7 and on down to get F. Obviously, F would be the entire 4 bits. That's the entire range there. So it'd be from 0 to F/64. So that would get everybody. So just be aware that the aggregate address prefix length, that works exactly the same. You just have to be a little more careful with your summary addresses. So you've got the 62.0, 61.60, and that gives you 0 to 3, then 0 to 7, 0 to 615, which is 16 addresses. Just so on and so forth. Not the easiest thing on the planet, but not terribly hard either. So, and folks, that's it. That is BGP's basics. We will be going over BGP advanced metrics and the metrics next week. Do you have any questions for me?
It's not about BGP, but when did you say the CML license would end for you?
June 20th is our license ending. So, and I'm not going to cut off your lab access after the end of this class.
I was going to ask you about that.
Technically ends what, June? When does it end? May?
I thought it was like May 13th.
Yeah, May, whatever. I'm not going to turn off your access to competitions. I'm not going to remove you from the class. So you can keep using it till it quits working.
Okay, that's what I was going to ask.
My goal, I'm working to try to extend that license. Here in a minute, I'll tell you some information that I'm not going to put on a recording. But we'll discuss some more in just a second about that. But June 20th is the drop dead date right now.
Okay.
I have a question.
Shoot, brother.
Regarding this CML virtual machine, the reason that we cannot copy paste from physical machine into virtual machine, this is limitation of CML VM, or this is some sort of your IT department put that limitation on?
No, the limitation is that we're running, you got to understand, you're connecting with HTML5 to the NetLab system. So you're using a web browser to connect to a virtual machine. And then we're booting another virtual machine inside of that. So we're kind of 2 layers deep. So it's because of the virtualization that we're doing and the fact that we're really 2 layers deep that's causing the problem with direct copy and paste. So that's why.
Oh, okay. Because on the other course that I'm using for DevASAC, it is basically we have, I think, 2 virtual machines there, and it's working very well. Basically I copy and paste from my physical machine into that one, and it's working without any problem. So maybe
but Ali, you're running it locally, aren't you?
Locally.
You're running. So in other words, you're doing the DevNet class, correct?
Yeah.
Okay, so you've got the DevNet machine in VirtualBox on your local PC.
Yes, exactly. Yes.
So in other words, all you're doing is you're copying from your local PC into VirtualBox, which is a local box. What
Mhm.
we're doing though is you're connecting to, imagine your PC is sitting out on the internet and you connect to that PC with an HTML interface. So you've got an HTML interface in front of this PC that we're doing virtualization on. So that's why you can't copy and paste from your PC to that PC, because you're not running CML locally. That's running on a virtual machine inside my environment. You're just and truthfully, all you're passing between your computer and NetLabs is the keyboard commands, and your mouse commands, and the monitors being shown to you. That's it. So you don't really have full access to the virtual machine, and that's why.
Okay. Thank you.
All right, folks, I'm gonna stop recording.